This is a presentation of SBE 15, New York City.
Hello and welcome. My name is David Bialik, and this is a joint presentation of the Society of Broadcast Engineers, Chapter 15, and the Audio Engineering Society, New York section. Before we start today's meeting, I want to thank Rowie Shamir and Jeff Schick and Angela Paiva for helping prepare all of this and doing all the back end work. So today we're going to be discussing recommendations for loudness of internet audio streaming and on-demand distribution. And we will be going over the new recommendations put in by the Audio Engineering Society's Technical Committee for Broadcast and Online Delivery, paper TD1008. We are honored to have some of the authors from the drafting group here today. We have Robert Orban, Bob Katz, and the person that edited the document, John Kean, as well as myself, who is one of the chairs of the TCBOD, Broadcast and Online Delivery Group. So I want to first explain to you what the group is. We are not writing a standard, we're writing a recommendation. Yes, sometimes our recommendations get elevated to standards, but right now this is a guideline, and we hope it will be helpful in your recording and streaming careers. We at the BOD, we have many different initiatives, and you can look at that on the Audio Engineering Society website. And currently, now that this paper is out, we're now moving on to a guideline for utilizing metadata in broadcast and streaming. So I encourage you to look around, and eventually we'll be putting out a call for new members, and we hope that you will join. Now, without any further ado, I want to introduce John Kean of Cavell, Mertz and Associates. John was, I'd like to say, kind enough to edit, but I feel like he was our victim that he edited. This document was not done hastily at all. For over 2 years, and we were meeting 4 hours every week working on this document. And you can download the document at the website, and I hope that's being put into the chat now. So, John, I'll let you take over and start your presentation. John Kean.
All right, thank you, David. It was really not an ordeal for me. When you see the group of people I got to work with, it was really a pleasure. So I was really honored to work with the rest of the group. Pardon me. Let me see if I can get my sharing working here and set it up so I can see my own notes. I trust
it's working, John.
Hello? Yeah, hi, Bob.
It's working.
Good. Thanks for the feedback. I was about to ask. All right. So these slides are mostly a reprise of what I presented to the AES convention in October, and have worked with a slightly shortened deck. Well, actually, a considerably shortened deck. It really started from 25 slides, and I've pretty much cut that in half so that I don't bore you with a lot of detail and time. And that'll give me an opportunity to hand it over to Bob and Bob to make their presentations and take questions from all of you. And if I can get myself going, there we go. So in the first slide here, we're showing online audio services, and that includes streaming and on-demand playback, which have been growing steadily over the last decade and is now a $10 billion industry. Although David just told me today that he has some new data that shows even greater growth for this year. So we might expect this is growing faster, but probably you're going to be attracted to just the rate of growth that's going on here. Well, the Audio Engineering Society foresaw the need to specify audio loudness and other parameters for online audio services. So it published a technical document 1004 back in 2016 as its first effort. That project and the new technical document 1008 originated within the Technical Committee for Broadcast and Online Delivery. It was evident that this committee, which was a 90-member group together, couldn't write a new technical document. It was simply too large, and a smaller group was needed to reach consensus. So the drafting group, as it was known, was formed with 10 members from that study group with me as editor. The group began in early 2020 with weekly meetings, but it soon started twice weekly meetings, as David mentioned, 4 hours per week for a year, plus a ton of emails to craft a new document. So what do we mean by distribution of audio-only content? For this TD, our recommendations are for entities in the delivery chain tasked with normalization of content loudness. This is before streaming or download by end users. These are typically a branded streaming service, an on-demand content provider, or online radio station. The new TD focuses on distribution of audio-only content to consumers rather than recommendations for content creation. However, content creators and producers should find it valuable to their work. It's not intended for sound with picture distribution or video. There are already guidelines in place for video and sound with picture content, as you know. The primary goals of the new TD are to, first, establish appropriate loudness for streaming and on-demand file playback using ITU loudness measurement, to optimize distribution and the listener experience, to recommend a consistent real-time production loudness target for streams, to ensure loudness consistency between sources, such as on-demand files, interstitials, streams, and so on, to prevent excessive peak limiting and other processing from degrading perceived audio quality. That's something that is really important to me. And finally, encourage the use of audio metadata. So this slide is a table directly from the document, table 1 as a matter of fact, and it summarizes the document's recommendations. But as you can see, the document, or the table rather, is complex. Well, frankly, the whole document is quite large and takes some careful reading. So we're going to break down this table by content, which is really the heart of the document, in the following illustrations. This illustrates the techniques for album and track normalization from that table 1. The original album in our example here in this slide is an album with 4 tracks, and it's shown on the left. Each track of the album is measured, and the integrated loudness is shown by the dashed bars. So you can see those bars rising and falling depending upon the individual loudness of each track. In album normalization, the loudest track, which in this case was -11 LUFS, is adjusted to the recommended distribution loudness of -14 LUFS. The same -3 adjustment is done to the remaining tracks in this example, and that's album normalization. Studies show that the spread in track integrated loudness within albums is about 2 or 3 LU. This method preserves the original differences between the songs. So as you noticed in the animation, all of the tracks move downward together. In track normalization, each track is lowered by different amounts to provide a uniform loudness of -16 LUFS. This would apply to most radio-style streams. However, this technique alters the differences in loudness of the original tracks. Peak levels of the original tracks may exceed 0 dBTP, but in this example, peak limiting is not required because the levels are always reduced. Wide dynamic range content, such as classical music, has special considerations which are discussed in the document. Table 2 is part of the document, and it's particularly relevant to distributors using radio-style audio processing. Some providers, such as commercial radio stations using radio-style audio processing, cannot control speech and music separately. They should instead use a single distribution integrated loudness for the entire stream. Table 2 shows examples of radio-style formats and integrated loudness for each that will interoperate well with streams where speech and music loudness are managed separately per Table 1. For example, a format that is news talk is primarily speech and should operate at -18 LUFS. A format that is primarily popular music can operate at -16 LUFS, while a mixed format is recommended at around -17 LUFS. Integrated loudness applies to the entire stream, so providers will balance the loudness of elements within the stream as they prefer. This is a good thing to keep in mind for our document, some of the background. It's important to note that the TD1008 is part of an industry process that's evolving to a system of loudness and DRC, that's dynamic range control, metadata within all online content to provide loudness management features to help in things like noisier listening environments, as well as to provide full dynamic range content when desired by listeners. Loudness and DRC metadata are already well established in video production and distribution. Audio content in consumer players is emerging now, but until metadata is added to online content and players support it, TD1008 provides for loudness that is well suited for current fixed and mobile listening. TD1008 is creating an awareness for metadata encoded streams in future consumer devices that comply with CTA 2075. That's the document you see on the right. The document provides a large section with technical notes on subjects ranging from adding interstitial content, such as commercials, and automated announcements, to music and speech content, controlling peaks when normalizing audio loudness, dealing with monophonic distribution, and more. There's a full glossary for technical terms and a bibliography of related research, industry standards, and relevant technical articles on loudness. Let's turn to some demonstrations of what MPEG-D, that's the dynamic range control, can do for audio playback. In this case, I'm not going to play the audio samples because of the complexities of our Zoom meeting, but I will illustrate them with some examples visually here. You can see the waveform envelopes, left and right channels here for some audio material. This was produced at -24 LUFS, which is the recommended loudness for production, at least for video content, and we hope someday for all audio for video content. You can see a small thumbnail here of the measurements, -24 LUFS. The loudness range is 14.8 LU. Now we'll move on to the next example here, where dynamic range control has been applied, and we're showing that the loudness has actually been raised to -18 LUFS, and the loudness range has been reduced to 11.8 LU. This is done through gain compression, peak limiting, and other processes that are handled in the decoder. Again, this is something in the future which we trust will be a part of all online audio content, and will be supported by players in a few years. This is really after TD1008 has served its purpose to manage content where these dynamic range controls are done at the distribution end. Finally, in this slide, we're showing the content has been raised by the DRC control in the player to -14.3 LU, and the loudness dynamic range is reduced even further. So that's the kind of management that would be useful, let's say, in a noisy environment, like writing in a bus listing on your earphones. But the nice thing about this eventual system is that it would be selected by you in that environment, where other listeners who may be listening in a quieter environment could select either the original dynamic range or something managed in between. So that gives you kind of a thumbnail of of some of the process discussed in the document. And at this point, I'm going to hand it back to David and to Bob for their presentations and questions.
Thank you, John. Before Bob Orban speaks, I want to remind everyone that we did not take any of this lightly, and instead of voting on this, we all had to come to consensus, which means everybody had to agree. And considering that there were a number of people, it was quite a job to get everybody in agreement. So none of this stuff was done lightly. And I also want to remind you that you can download the paper free at the AES Technical Committee website, and I believe Angela has put up the link for that. So now we have Bob Orban of Orban Labs, and in all honesty, a legend in the audio industry. Bob.
Well, let's see if this legend can get his screen share to work. Okay. So can everybody see my slide?
Yes, we can.
Okay. So I'm going to talk about the applicability of TD1008 to broadcast style applications. So the first question is, in the context of broadcasting, who exactly is the creator? The recommendation is for distributors, not content creators, but this can create ambiguity in broadcast style production. When creating a produced broadcast stream, such as contemporary hit radio, with DJs talking over music and so forth, who exactly is the content creator? There are often two layers of content creators. First is the creators of the music and other pre-produced elements like commercials and promos. And that, I think, is mostly what we think of as the content creation. But there's also the broadcaster who creatively assembles these elements, often adds DJ speech, and streams this program to audiences. There are two styles of loudness control. John's presentation covered static normalization fairly thoroughly. This is the technique that's described in Table 1. Its great advantage is that it preserves the creative intent. That is, the dynamics and the spectral balance originally intended by the artists who created the Layer 1 content. But there are several issues to actually doing this in a broadcast style environment. First of all, it requires complicated pre-production to implement album normalization. And if you already have a playout system with 3,000 or 4,000 cuts on it, then you really can't go back and do what's necessary to implement album normalization. So album normalization is mostly useful for newer loads of a playout system where you can actually go back to the sources. Another issue is that album normalization might be ineffective when music is sourced from compilation albums, because in that case, you do not have access to the loudest cut in the original album from which the compilation track was taken. Another issue is that static normalization is marginal during crossfades unless the crossfade uses an equal power law. It can also cause awkward sounding transitions, particularly if program material starts quietly. So if you have a high energy DJ going into a quiet intro, this may not be what the broadcaster wants, depending on the format of the broadcast. It's impractical for automated voiceovers where you're mixing two normalized elements, and of course then the loudness is larger than either of the source elements. And finally, it's challenging for live production. Live production requires the operator mixer to monitor the production using a loudness meter and to adjust levels so that they meet the desired distribution loudness. In live production, ripping, normalizing, and playing out all elements except for the announcer or presenter can help, particularly if you use a mic processor for announcer to control the loudness of live speech. So as an alternative to static normalization, there's traditional online audio processing, which broadcasters have used for 60, 70 some odd years. This allows the provider to specify the desired distribution loudness as a parameter in the audio processor and adjust the dynamics of the program material to match it. Whether or not to use radio style processing is both an artistic and business decision and depends on the goals and target audience of the provider. Radio style processing achieves a comfortably listenable sound with consistent spectral balances, texture, and loudness between sources, including speech and music. Broadcasters' long-term experience with audience reaction, as measured by rating services like Nielsen, have shown that radio style processing appeals to many audiences. On the other hand, other audiences may want to hear the original sound of the program material without alteration, except for static normalization. This is a matter of preference, and it's okay for different people to prefer different things. Traditional online audio processing changes the dynamics and spectral balance originally intended by the artists who created Layer 1 content. So it does not preserve the original artist's creative intent. However, it does handle crossfades and voiceovers gracefully. It smooths transitions, particularly when music starts quietly. It works automatically without operator intervention or special pre-production. It makes live production easier, particularly in combo operations, so DJs can concentrate on their performance without worrying much about levels. And it allows netcasters to create a signature sound that has more source-to-source textual consistency than static normalization provides. So let's look at table 2 again. John covered this in his presentation, but I'll just do a little review of it. It requires setting up the processor to produce a desired distribution loudness to make streams interoperable with statically normalized streams using table 1. And as John said, table 2 serves the recommended distribution integrated loudness for several typical radio style formats, ranging from minus 18 to minus 16 LUFS. And basically this came about because table 1 recommends minus 18 for speech and minus 16 for track normalized music. So the values in table 2 are simply a linear interpolation between minus 18 and minus 16 based on the approximate proportion of speech to music in a given format. And because this only shows 5 formats, providers may further refine and customize these values depending on the proportion of speech and music in their specific streams. So the formula that you see on your screen is just a simple linear interpolation formula. It's also found in the TD1008 document. Traditional online audio processing certainly gains benefits from static pre-normalization of all content in a playout system. So in other words, it's much better to not just take the raw data from the CD or whatever source you used for your playout system, but to go through and to statically pre-normalize all content on a track-by-track basis. And because the online audio processor is going to do the final polishing of the sound, all you need to do is track normalization of every item in the playout system. And if you pre-normalize in this way, a good target is minus 24 LUFS if the normalized files are 20-bit or higher. Except for some classical music, minus 24 LUFS doesn't require upward normalization. So there's no need to apply peak limiting during normalization. Minus 24 future-proofs content in the playout system to accommodate the evolutionary process that John talked about, where the distributor and player ecosystem uses loudness metadata for normalization. And finally, let me talk about wide loudness range material. Loudness range, LRA, describes the variation of loudness levels within a program on a macroscopic scale. It's not to be confused with dynamic range, which is the distance between the noise floor and the highest possible peak of a signal path. LRA is based on statistics and uses 3-second short-term loudness levels. EBU Tech 3342 gives you a lot more information about how it's actually done. As the loudness range of program material increases, the integrated loudness becomes less and less useful to describe the program. Some classical music, when just transmitted with full dynamics, has a very high loudness range. It is often unwise to statically normalize this material to a given target integrated loudness. Instead, you can transmit the material without alteration and normalize the loudness of speech announcements and any interstitial materials like commercials so that they're well balanced with the louder parts of the program. However, there are some caveats. Some players have insufficient maximum gain to provide satisfying listening levels. Also, some audiences may find material with very high loudness range frustrating to listen to because the quiet parts get lost in the ambient noise of the listening environment. Transmission systems that support dynamic range control metadata allow listeners to apply dynamic range compression on playback if they wish. If your transmission system doesn't support DRC metadata, applying modest amounts of parallel compression prior to transmission of classical music can be very useful. And parallel compression is the process of compressing the original input material and then adding the output of the compressor with the original material with appropriate time delay in the original material path to compensate for the time delay of the compressor. And the effect of this is to maintain the dynamic impact of the louder parts of the program so you get the nice punch of the crescendos in classical music, the fortissimo sections. But at the same time, as the music gets quieter, the compressor output becomes a larger and larger proportion of what you're hearing. So you're still able to clearly hear the quiet parts of the program material. So that is my presentation. And let me stop my screen share so we can move on to the next presenter.
Thank you, Bob. And I now want to introduce noted mastering engineer, author, presenter, and I'm proud to say someone I've known for many years, Bob Katz.
Too many years, David. Oh, thank you. Thank you, everyone. I hope you're enjoying our presentation. I don't want to duplicate what John and Bob Orban went over. So let me show you what I want to concentrate on as a music mastering engineer. First thing is, do you all see table 1 on the screen? Hopefully
Just fine, Bob.
Oh, great. Okay. And my cursor moving around?
That too.
Oh, wonderful. Okay. So this is the area that I'd like to concentrate on today, and that is talking about music reproduction in a normalized context. Now, we could talk about the why, the when, and the how. And the when you should use either track normalization or album normalization. Bob Orban got into that a little bit and covered some of the criteria. And but I would have a lot more to say about the when, but I want to start with the why. Why would you want to use album normalization over track normalization? And then maybe we'll have another meeting sometime about the how, technical aspects of metadata, broadcasting situations, DJs, announcers, pop music shows, classical music shows. But I want to introduce, especially the broadcasters watching this, to the whole concept of album normalization, because it's a strange concept. It was a strange concept to one of our drafting members who is an eminent broadcaster, and he was very impressed by the whole idea. And after I showed the idea of album normalization, everything clicked in place. So I'd like to talk about why a little bit and introduce you to it. And then you might have questions about, well, how do I get this done? And when do I do this and when do I choose it? If we have time, we'll take some questions on that. So the general idea is that if you're doing track normalization, the loudness target that the streamer we recommend go to is minus 16 LUFS. And if you're doing album normalization, the album loudest track, we would like to recommend that you target that to minus 14 LUFS, but in both cases using attenuation only. So if the peak level would exceed minus 1 dB true peak, if you raised it, then either attenuate it or leave it alone. That's one of our recommendations. Or you use peak limiting, which is another possibility, but that gets into the how. I want to talk about the why. So that's the general idea. And the other thing that TD1008 recommends is that album normalization is preferred. Now, what Bob Orban just talked about is he has a large orientation towards doing track normalization, and he explained a lot about why it might be a preferred thing. And I'm going to talk about the aesthetic aspects of album normalization and why we music producers would prefer that if you can, you use album normalization wherever it's appropriate. And that, of course, would be the how part of it all. So let me show you a little presentation. You all see that little diagram showing the highest peak of the song and so on? Tell me yes, I hope.
Yes, we see it.
Great, great. Okay, so in yellow, we see the highest peak of a song and the range of the peaks. And in violet, we see the range of the loudness range of the song. And in the little dashed line, that would be actually the integrated loudness of the song. I shouldn't have written average loudness. That would be the measured integrated loudness of a song. Now, let's say that you're playing on Spotify or Tidal or Qobuz or Apple Music or Amazon Music, and you have a playlist and you mix a Beatles album with a Sinatra album. Now, if your system is not normalized at all, in that section on the left, without any normalization, I'm going to tell you nothing works right. Here are two artists that are very different from one another, but maybe you're a fan of both of them. And let's look at the Beatles album on the left. I should have had a pointer, but I'm going to describe it. I'm sure you can see what section I'm talking about. Excuse me. So the first bar, we have a loud song by the Beatles, and its loudness is represented by its dashed line. And then we have, for the second bar, a soft song by the Beatles. As you can see, it's softer. The dashed line is lower. And then this Frank Sinatra album sounds way too soft. The third bar, in fact, the loudest song on the Sinatra album turns out, in this case, this example, to be as soft as the softest song on the Beatles album. It's way too soft. And the softest song on the Sinatra album in the fourth bar is even softer. So without normalization, these four cuts don't play together, and your listeners will not be very happy how that works. Now we have in the next four bars, section B, an example of track by track normalization. And we musical guys would tell you the problem with track normalization is that the loud numbers don't swing. Let's see, the Beatles' loud song, that would be the fifth bar there under section B, the first bar under section B. The Beatles' loud song is set to the target level, which in TD1008 would be minus 16 LUFS. And the Beatles' soft song is set to the same target level. And the Sinatra's loud song has been brought up, so now everybody can hear it all at the same loudness. but the Sinatra soft song is just as loud as its loud song. And what I am telling you that this is, in reality, is track normalization is upward compression. It's manual upward compression. Just like you took your fader, you can still compress with a fader. And that's exactly what's happening, is you've compressed, you've brought up the soft songs, and you've made them just as loud as the loud songs, and the loud songs have lost their impact. They don't swing. So, guys and gals who are watching, track normalization of an album has negative consequences for people who are listening attentively. Now, if you're listening in the background at soft levels, there are maybe some real meaningful advantages, and if you're dealing with a noisy environment. But I'm talking about the musical ideal. Someone perhaps listening to title and a playlist, or maybe in a real high-end broadcast station. No, you're all high-end. What I'm trying to say is a broadcast station that would like to broadcast dynamic range for attentive listeners, maybe a classical music station. If you do track normalization, it has negative consequences. So let's talk about why we would need album normalization. And over there in section C on the right, what I'd like to tell you is that you can play the Beatles, which is rock music, in the same playlist with another genre. In my case, I picked a big band with Frank Sinatra. And what the album normalization does is it places the Beatles album Loud Song, that's the fifth bar over to your right, from the left, fifth bar from the left, the Beatles album Loud Song at the same loudness as the Sinatra Loud Song. So you can see, looking in section C, the loud songs are at the same loudness. And relatively speaking, the soft songs are, it looks like the soft song on the Beatles album and the soft song on the Sinatra album are at the same loudness as each other. And that's really not a coincidence, because a good pop music mastering engineer generally doesn't put the soft songs, as Bob Orban mentioned, more than 2 or 3 dB below the loud songs. And for those of us who are keeping track of it in a reasonable environment, I don't mean when you're in the kitchen running the dishwasher. I mean when you're in the living room listening fairly attentively, and you don't have the windows open and the traffic isn't coming through, 3 dB or 3 lu between a loud song and the soft song is not excessive. And this sounds very, very natural and very musical. And well, I'll tell you, the artists would appreciate it if you would make a consideration about album normalization, just for the reason that it sounds musical, and it swings. It really does. And what you can do is, if you as I just showed you, if you can match the loudest songs from each album, you can often have different music genres work together. So, I mean, back when I was a progressive prog rock DJ, anything went. I would play a section of a classical album, I would play hard rock, I would play electric rock, I would play folk music, and so multi-genre existed back then. Nowadays, most radio stations are segmented and they follow a certain format, and there is no longer what we used to call progressive formats that I've seen. But if you have the kinds of taste that I have, and you like many different styles of music, this section C over there on the right demonstrates that you can shuffle your playlist and everything feels just like it was mastered. And so that's my case. We've talked about the why. If we have time, we can talk about how do you do it, and when do you do it. But there we go. That's my presentation. That's the whys of album normalization.
Thank you, Bob. And I would like to bring up the topic of why did we start this and this really tough job of getting this done right. Up to recently, I was a director of streaming for a major broadcaster, and it really bothered me then when people were listening to the stations, they'd be listening to the music, and then the commercials would come on, and they'd be 6, maybe 7 dB louder than the music, and there was no consistency in levels. And that's what started this whole discussion many years ago. This paper took 2 years, but remember, we did TD1004 before this, and we had many discussions going back to the year 2000 on what was happening. And it's taken us a long time to get to the point where we feel we have it under control. And I really want to encourage people to read the document, download it. You can't say it costs too much. It's free. It's at the AES website. I highly say, give us the attention of reading it. You might not understand all of it. I know I didn't understand all of it the first time I read it. It's a lot to understand, but it will help your product in the long run. Now, we're going to have some questions. And John, did you have anything else you wanted to add before we go to questions?
No, I look forward to the questions. I have a few items that I noted, but I'll circle back with those after we hear what people are asking.
Okay. First off, I want to just point out, as people will look at our presentation and our paper, and we all know that the measurement of loudness is LUFS or LKFS. And for this paper, Bob Orban, you can correct me if I'm making light of it, the numbers in LUFS are equal to LKFS. Am I correct?
No, I think that's important because it can be confusing. It's just nomenclature. LUFS and LKFS are exactly the same thing.
Okay, and both Bobs, do you want to go a little into how we derived these numbers? Because we didn't pull them out of our hat. These numbers, I think table 1 took, what, 3 months of debate alone to get it right?
I could give you the why a little bit. Let me share the screen. Where's the share screen? Here we go. And that would be this. Share. Okay, so this is table 1, and people are going to say, well, where did you come up with these 18, 16, 14, etc. numbers? Well, it all started with speech. We went through quite a bit of debate and discussion as to what would be a good loudness number for speech. And remember, as Bob Orban and John Kean mentioned, this is going to be an evolutionary process. We wanted to find a number that would work for portable devices that have limited headroom and limited gain. And through a lot of both some formal study from some of our participants and also just practical experience, we arrived at minus 18 number for speech. And that includes podcasts, by the way. Podcasts that are largely speech, the speech segments of podcasts, we recommend being at minus 18. And I'm going to throw in a little bit of an observation. I wish that Rob Byers were here, but I'm going to say that we highly recommend minus 18 for speech, especially including podcasts, because some podcasters are practicing a minus 16. And when you listen to the two different styles of sound and processing, it turns out the minus 18, that's without any dynamics processing applied, I'm going to say. dynamics processing can bring a whole nother question into it. But let me just say that on an absolute basis, if you're just listening to speech recording, if the speech integrated loudness ends up at -16, it sounds a little bit squashed, a little bit undynamic, and loses some of its impact compared to -16. At least that's my listening experience, and others of you who are here may differ with me on that, but that was the practical reason why we ended up choosing -18, that it wasn't too high and it wasn't so low that the devices would run into trouble, especially the portable devices. And so it all built from there. We ended up with a -18 number, and then we worked on the principle that research that's shown in our paper shows that the difference between speech and music in a combined program, that listeners are more comfortable if the speech measures lower than the music by, and I'm going to say at least 2, 2.5, or 3 dB. And in the case of Metropolitan Opera broadcasts, a wide dynamic range where you have an announcer and then the orchestra, you might see the announcer at 5 or 10 lu below the integrated loudness of the music. But for, I would say, the vast majority of, well, let's just say popular music broadcasts with a DJ, 2 or 3 lu difference is enough. And that's how we ended up with -16 recommended for the music, because it came from the speech. Then, do we have time so I can describe how the album loudest track ended up at -14? Do you want me to go on?
I think you should, because it's really important. And I'm going to say something that most broadcast program directors will scream at. Louder is not always better, because you want to be able to hear some dynamic range.
David, you're breaking up.
Personally, I think you should be able to distinguish the instruments. I'm sorry. But
I was saying, David, you're breaking up. You might want to kill your video, see, because I lost you for a second. Okay. Okay, I'll just go on briefly. No, louder is not necessarily better. Good dynamic range is very desirable. Not too much for casual broadcasts, but for even for serious broadcasts, some dynamic range left sounds nice. And so when we ended up with the -16 as being 2 lu above -18, then when we talk about album normalization, it turns out that in an album, if you measure the integrated loudness of the whole album, the loudest track typically, depending on the aesthetics, ends up about 2 lu above the integrated loudness of the whole album. So we ended up with 2 lu above track normalized for album normalization. And in many, if not most albums, you'll find that the integrated loudness of the album will fall around -16 if the loudest track is made to be -14. Now, it's a compromise number in the sense that it doesn't leave much headroom for dynamic music with a lot of microdynamics and a big peak to loudness ratio. But yeah, hey, I think that's for another time, another discussion. You asked, how did we end up with these numbers? That's how we ended up with these numbers.
Could I jump in here?
Sure, of course.
Yeah, one of the members of the writing group, Ilko Grimm, did a massive study with millions of songs of the loudness of currently released popular music. And another reason why -14 was considered acceptable, as I believe it was chosen so that something in the order of 95% of the tracks that ILCO looked at would not have to be upward normalized to use this. So there would be no extra peak limiting needed.
Yeah, these numbers did not come out of thin air, as David was telling us.
Okay. And in the same regard,
Want me to stop sharing it or keep it up?
I think you can keep it up for a little bit because this is very important. Now, this is an evolutionary process. It's our hope to eventually be compatible with what's going on in television and ATSC3 and what was done then. And Bob Orban, can you tell us exactly what the differences are between ATSC3 and TD1008?
Well, basically, it's 6LU.
That's a good one. We should put that on a t-shirt.
I mean, the history of loudness normalization really dates back to the era of the COM Act, which was passed by the US Congress, I believe around 2008 or so. Anybody has it? And that required that the commercial announcements on broadcast and cable television and satellite not be louder than the surrounding program material. So the ATSC got together and created a document called ATSC A85 that recommended loudness control for commercial and promo elements. And it was a complex document in that it's provided for both so-called fixed metadata and agile metadata because the Dolby AC3 codec used in digital television in the United States had a metadata element called dial norm, and that allowed the volume control of the receiver basically to be operated remotely in such a way that the dialogue loudness would be consistent regardless of the actual loudness of the raw audio material on the track. But it turned out that maintaining a full metadata path between production and transmission proved to be quite challenging. So these days, virtually everybody is using so-called fixed dial norm. And the recommended level for that is minus 24 LUFS. It was fortunate that about the same time that A85 was created, that the BS 1770, the loudness standard used in both A85 and our current document TD1008 was published. So that was basically the history, and the intent was to allow enough headroom so that digital television broadcasters could broadcast even very wide dynamic range movie mixes without requiring peak limiting, or the maximum may be a couple of dB. And so we have had this in place in the United States for about 12 years now. Europe has a similar recommendation called EBU R128, and it recommends minus 23. The historical reason why it was not minus 24 was that I believe it was based on BS 1770-2, which is when the level gating was first added to the BS 1770 algorithm. But it's only a 1 LU difference anyway. So video providers have been doing this for a long time, and TD1004, and now our current TD1008 is basically harmonizing the audio-only streams with what video broadcasters have been doing for about a decade.
Bob Orban, can I elaborate for a second about the difference between the ATSC and the R128?
Sure.
Because it turns out that they're actually, when you look at it one way, they're exactly the same, because the EBU tolerance is, I believe, plus or minus 1 lu. So if you take minus 23 plus or minus 1, and ATSC is plus or minus 2, right? So, or is it plus or minus 1? Oh, anyway, if you look at the tolerances, you could say they're both at minus 23.
Yeah. Anyway, it's close enough. It's only one dB.
What's a 1 dB between friends anyway?
And
I can't sleep if it's a dB off, David.
yeah, a paper from Dolby several years ago determined the range of loudness variation over which listeners would be unlikely to want to change their volume controls, and it turned out that that was +2 and I think a -4 LU. So, given that fact, 1 LU is well within what they call the comfort zone.
Okay. I have a question here, and to this day, I can't explain it properly, but how would you explain, in a simplistic term, integrated loudness versus distribution loudness?
Well, integrated loudness is a unit of measure used by the BS 1770 loudness measurement algorithm. And distribution loudness uses integrated loudness for the specification.
Right. It's not a measurement.
Okay.
Distribution loudness is what we're talking about here as content. And that's the content which is transmitted, you might say, or distributed from a point of origination to the consumers, to the listeners.
Okay. Phil Hartman asks, how are you measuring LUFS in real time?
Oh, Bob Orban.
That was a bone of great contention and discussion in the writing group. And the answer is, it's sort of hand wavy. It's measure it long enough so that you get a good sense of the loudness impression of the program. You don't want the integration time to be so short that it is significantly influenced by given tracks that you're playing. So, a rule of thumb might be integrate for an hour or so.
What about your rolling loudness meter, Bob?
Well, that allows you to choose the integration time. And an important concept to understand is that BS 1770 does not use so-called exponential integration, where the more recent events are weighted higher than events in the past. Instead, you have to imagine a sort of rolling integration that moves along the audio and weights every element within that time period exactly the same, so that the material that you just heard is weighted equally with the material that was heard, say, an hour ago.
Yeah, it might help to point out that in this table, we're specifying integrated loudness, which, as Bob said, is measured over some period of time, usually a long period of time, like the length of an album or the length of a radio program. It is not real-time loudness, but we do have loudness meters that do give real-time indication. And the expectation here is that if you mix your content so that it indicates at one of these loudness values described here, that if you're consistent enough with that, you'll tend to converge on the ideal integrated loudness values that we specify. So it's really a matter of experience with using the meters and having a feel for that.
So
Right,
strictly speaking, BS 1770 calls for the integrated loudness to be performed over the entire track or program element that you are measuring. So it's not really a real-time measurement. So when we were doing the Orban loudness meter, I had to, sort of make a command decision. Okay, how do you extend this to real-time loudness measurements? So we just decided to allow the user to specify an arbitrary length of integration that would roll along and always start with the present time and then look backwards in time as long as the user set it to be. And this is pretty flexible because you can set it anywhere between 1 second and I think 3 hours in the meter. And of course, the longer the period of time, the less it's affected by momentary loudness of the program. And when I described earlier classical music with a large LRA and observed that the integrated loudness becomes less and less significant as the LRA increases. This is somewhat taken into account by the gating mechanism of BS 1770-2 and higher, because there the loudest parts of the program are used to measure the loudness, specifically anywhere from the loudest part to 10 LU below the loudest part is the only part that's integrated in the current version of BS 1770. So as you get these large loudness ranges, you get further and further away from the spirit of the gating in BS 1770. And it becomes more and more useful just to look at in classical music in particular, the forte and fortissimo parts of the track for doing loudness normalization. And this is also consistent with Bob Katz's idea of album normalization.
Mm-hmm. Yeah, well, I have an idea for R128 version 2, and there's been some, I've raised some feathers in the loudness group about that idea. It's going to be a long while before we settle all these little nits that we can pick.
Yeah.
Yeah, David, how much time do we have? Or how are we doing on time?
We can still go.
Good. Well, I was going to say that based on what I was just hearing, that I imagine some of our listeners today are rolling their eyes. People who are kind of new to this technology and are wondering, well, I don't have that much control over my audio, or I have never heard about anchoring to speech. And those kinds of technical matters. And I'll just point out that if you look at table 2 in the document, which we showed earlier, that's a good starting place if you're just getting used to it. The purpose of the whole document, and including table 2, is to make sure that levels perceptually are consistent in loudness for listeners, that we're avoiding annoying listeners when they change from, say, a stream they're playing back in their car through the dashboard to their audio system, and they switch over to a podcast, and they hear a large difference, either increased or decreased. That's annoying to listeners, and it forces them to have to reach for the volume control, which in the car is increasing your risks. So one of the things we want to do is make sure that listeners become less annoyed with jumps in loudness. And the other is that with the target levels that we describe in Table 2, we're proposing that we cause no harm or minimal harm to content that's already been produced by not forcing it to be compressed dynamically any further. There's already enough dynamic compression being done in the content that we listen to. So, for example, if you are responsible for distributing popular music, those levels that are listed there, such as -16 for track normalized content, is a good place to start and is well below the average loudness of commercially produced content. As we've talked about at AES shows, much of that content is well above -12. It might be -10 LUFS or even higher. So by downward normalizing it to -16, we're not introducing any impact on the audio. We're simply making it more consistent from source to source.
I want to point out something that I normally say. The consistency is very important, and getting your loudness consistency is incredibly important, because if you're not consistent with your loudness, you're going to encourage your audience to constantly fiddle with the volume knob. And if you're bringing the listener to the control, you are then inviting them to turn you off. Mm-hmm. So that is a major factor that I've always brought up on this. And
David, I'm going to interrupt because you once made a really powerful point about the transition to streaming from the old-fashioned radio, which is that they don't have a dial anymore to spin. They find you by, a URL.
You're a destination now. Yes.
Yeah. So as a result, the whole idea of are you the loudest station on the dial no longer has as much relevance. Would you agree?
Oh, I totally agree. If you're streaming on, let's say, a radio type player, you're not going to be going down and having someone jump out at you 5-6 dB louder than everybody else. So why not be as clean as possible? Let the mastering engineer, Bob, let it shine a little. That if the music has a flute in it, let it have a flute. How many times do you hear something on the radio and you can't even distinguish the instrument anymore? I've always said that people that don't know how to process, you can always tell that when you can't distinguish a cymbal. Bob Orban, you probably agree with me on that.
Of course. Let me add that heavy dynamics processing, or the wrong kind of dynamics processing, can make speech less intelligible. And I think Bob Orban might want to elaborate on that.
One interesting thing about well-designed multiband processing is that it can sort of simulate both the speech music offset and album normalization. And the reason for this is fairly subtle. Each band in the multiband compressor has a fixed compression threshold. So the more bands you combine, the louder things are going to get. And one thing about soft and loud cuts on albums is typically the soft cuts are more spectrally sparse. The Beatles A ballad is going to have maybe a piano or guitar, whereas the Beatles rave up is going to have a bunch of electric guitars, loud drums, and so forth. And speech is also spectrally sparse. So well-designed multiband compression actually, by exploiting spectral density and spectral sparseness, does give you some of these desirable loudness offsets. Now, it's true that badly designed multiband compression can modify the so-called envelopes of speech, and that will contribute to loss of speech intelligibility. Well-designed multiband compression avoids this, and in many cases, if the microphone is, say, a little muffled, or if the environment, say, an outside broadcast or a news actuality is very much catch as catch can, then the multiband compression can actually improve the intelligibility.
What about proximity effect? I get real close to the microphone. How does compression and processing affect that? Does it make it better or worse?
If the compression is properly designed, and I can only speak for our compressors, we have a so-called DJ bass boost parameter. And the way that works is that our gain freezing gate will reset the gain of the bottom band, the bass band, to match the gain of the second to the bottom band whenever a pause in the speech occurs, so that you don't get this bringing up of the very lowest frequencies in speech. And certainly if you have a serious proximity effect and you set the threshold of the lowest band in the multiband compression properly, then that is actually going to reduce the effect of too much bass.
Some of the participants today may be engineers that deal with radio style streams and are wondering, well, I don't know whether I can twiddle with my stream loudness. I have to answer to others in management about this. But I can tell you that if you comply with the Table 2 recommendations, that you're already joining a large number of major radio groups that are already compliant with Table 2. So if you are, say, peak normalizing your audio right now and pushing loudness to high levels like -12 LUFS, you can lower it to the Table 2 recommendation.
Does our audience understand the difference between peak normalization and loudness normalization when you say that, John?
Probably, but by peak normalizing, that's the thing that we recommend against. We recommend loudness normalizing, which means joining others in measuring the loudness of your content and being consistent with the ITU loudness measurement. Peak normalizing means that you're reading a peak reading meter and you're probably running content loudness up to where peaks are nearly reaching full scale peak. And that is not a good place to be, because peak measurement is not a good representation of perceptual loudness. So you don't have good consistency from one piece of material to the next. And it also means that you're probably running loudness much higher than we recommend. And therefore, it may be annoying listeners who then have to grab for their volume control and turn it down. As Bob Katz was saying, people don't tune, let's say, to the loudest audio on the dial anymore. They tune to a channel or a stream that they want to hear. So there's every reason to join the movement toward using these consistent loudness recommendations. Maybe I'll also mention that Table 2 does address different genre. And if you're a producer of a podcast, for example, that's nearly all speech, maybe you just have an opening music bridge and the rest of it is speech, then we would recommend -18 for your loudness. Now you might say, yeah, but that's 2 LU lower than you're recommending for music. But as Bob Katz was explaining, and Bob Orban, there is an offset that results from using the loudness meter, which sounds better, sounds more consistent if you adjust your speech loudness to -18. It's no chance that we put speech the top of our table 1, because listeners do focus on the loudness of speech in the midst of mixed programming. That's what they adjust their volume control to.
And
So it's
I'd
important.
I'd like
that,
to reiterate a point that I made, which
Sure.
is you're not obligated to put your speech at -18 if you put your music at -16. If it sounds better with the speech even a little lower, go right ahead and do that.
True.
These are maximums.
Yeah, these are starting points, and you should always rely on your own ears, not automatic devices, to set the optimal levels.
And
But go ahead, David.
I want to add is a lot of times streams have interstitials or different segments coming from different locations, and you want to make sure that those levels are consistent. And that's how you asked before how you can justify it to your management. If you say, hey, my commercials are at this level, I want to be at this level because I don't want the commercials to be too loud to offend your audience, or you do not want to encourage the audience to touch the volume knob. That's how you justify it to your management. And you must also realize, and I'm sure Bob Orban will agree with me on this, when you're setting up the audio processing and your settings for your stream, it's not the same as doing it for over the air. They're different. They're different. And also for over the air, let's face it, people want to be as loud as possible over the air, but you don't want to be you don't want to be in total distortion in the digital realm.
Okay,
Correct,
well,
Bob?
yeah, I'll address that. I want to underline what John and Bob were saying about the artistic balance between speech and music. Specifically, TD1008 is a recommendation for distributors. So
Right.
the 2 LU offset between speech and music is useful if the distributor is doing automated assembly of speech and music. But it is not a recipe for content creators. Content creators should use their artistic judgment and their ears to create what is the ideal balance between speech and music for their particular program material. And that is a different thing than the recommendation for distribution.
Yeah, that's an excellent point, Bob. When I was talking about a podcast, which is mostly speech being produced at -18, that's assuming that the creator of the podcast is able to know that their content is encoded and sent to the listeners at the level they've mixed, they've produced. But it's possible that when they hand off their content to a distributor, the distributor, as Bob said, may introduce automatic assembly and readjust the loudness of their content. Nevertheless, we still recommend that speech and music be targeted and distributed at those slightly different levels in order to sound perceptually similar.
So
Go ahead, Bob.
going back to David's other question about setting up audio processing. No, you don't want to go for highest loudness. That's the whole point of this recommendation. And at -18, the audio processor is going to do very little peak limiting. It's probably not going to do any peak limiting at all for a lot of the content. So you get the benefits of multiband compression in terms of consistency and smooth segues, good voiceovers, and so forth, without the downsides that peak limiting can introduce in terms of distortion and or pumping in various combinations when the peak limiting is overdone.
Okay. I want to thank our guests today. I also want to thank SBE Chapter 15 and also Audio Engineering Society New York section. I want to remind people that next month's meeting will be on the history of Eventide. And I also want to thank Jeff Schick, Roe Shamir, Angela Paiva, and Conrad Troutman for helping make this happen today. And again, I want to thank John Kean, Bob Katz, Bob Orban. Thank you. And everyone have a good new year, and let's all stay healthy.
Thanks for joining us. Please remember to subscribe to SBE 15 New York City.